Good afternoon, and welcome to the session at 2:40 in the afternoon. Hope I'm not going to put you to sleep. The topic that we've chosen here to talk about is, it's going to be a case study. It's an example of a work that we have done in trying to achieve really high throughput and high resiliency in transactional processing systems, primarily addressing how banks are looking at transactional data, primarily as streams of events, streams of interactions, streams of relationships of data, and how do I really build transactional processing systems that can cater to the future generation banking. So that's what we're going to talk about. Let me caveat this. Unfortunately, I will not be able to name the bank because this is work in progress. It's fairly confidential, so pardon me for that, but it's a super regional global bank. My name is Kiran MR, I'm the Vice President and Chief Technology Officer for Wipro Digital. And this is my colleague, Raju, who was one of the key architects on the program, and is a distinguished member and Chief Architect in my team.
Hello, everyone.
To set the context, the bank had lots of challenges, as every organization has. The bank has been in existence for nearly 100 years. Tons of data that they have. Am I still audible? Yeah. Banks have collected tons of data, and the applications have grown over periods of time and have truly become heterogeneous in nature and have really become complex. Obviously, there were too many technologies that came in. A lot of those technologies started to coexist with the older technologies. Investments in new technologies started to grow, but on the other side, the older technologies never got retired. So it sort of created a humongous sort of an IT assets, and the IT debt started to grow. On the other hand, businesses started demanding, give me more real-time decisioning capabilities, give me data on the front, the ability to capture unknown sources of data. It's not just the transactional data that's required. I also need to capture social information. I need to capture a lot of first-party and third-party data from different diverse sources, and lots of mobile data, including geopositional data and other data. So help me to make real-time decisions. So that was adding to the complexity of the operational environments. And of course, technology started changing so fast. While they were still working on their data warehouses, moving from traditional data warehouses to Teradatas, to Hadoops, to real-time data streaming, technology started changing so fast. So there was too much of complexity in the operating environment. And to give a background, what was happening is the bank said, look, we have an extremely inconsistent experience on my customers. And to give you an example, they said, when a customer walks into a branch or goes to an internet portal, he says, I need data for the last 1 year for my taxation purpose. The banks was able to say, okay, here is your last 3 months data. For the remaining 9-month data, please wait for 24 hours. And that was a very poor experience, very inconsistent experience. And this inconsistent experience was not because of the inability of the user interfaces, the user experience, but it was the inability of provisioning the data at the right structure and the right schematic models in the front. And of course, quality of transactional data itself was a suspect because banks have traditionally grown through the batch era, and lots of data was curated only during batch cycles, which was getting elongated, so batches were never completed on time. So it used to take 2 days, 3 days to complete batch cycles at times. And as I said, transactional data availability on the front was a challenge because systems only had about 3 months of data that they could provision on the front. On the design or the structural complexity of the operating environment was there was too many performance and throughput issues. So more and more layers, more and more analytics, more and more models only led to more and more complexities in performance and throughputs. Too many product-centric, siloed approaches in the bank because they grew through acquisitions. Being a super regional bank, there are multiple instances of the same with varying degrees of complexity, too many changes to the localization and the local rules of different countries. And of course, there's too much of legacy and multiple points of failures. So we said if you were to solve all this problem, you really need to look at what's the fundamentals. Biggest challenge was, they said, look, my investments in my core systems have been over periods of time, and even today we spend about $1.3 to $1.4 billion on an annualized basis on the core systems. So obviously expecting me to remove those core systems is not going to happen overnight. So there are lots of design principles that we said we will have to drive and radically look at a very different solution that can coexist with the core systems, but slowly alleviate the problems that exist in the core systems onto the front end and build a nice new models in the front. So first design goal was how do we deliver a very consistent experience across all channels? And this experience was to be driven by analytics and not just by a great looking screen or a great looking experience on the front. Second one was there was lots of data that had too many data structures. I said there was a social data. There was a multi-model data that we had to cater to. And we also started looking at neural type data models because every customer interaction with a bank is a relationship in a network. So how do we start structuring data based on those relationships? For example, I make a payment, that's a relationship. I call up the bank for some inquiries, that's a relationship. All those interactions, how do you start structuring them in a neural network model? So how do I support for multi-model data structures? And these data structures are coming in at really high streams. And of course, large data sets, including all kinds of volumes and variety of data that had to be supported. So based on these fundamental goals, we said, let's define certain principles. So first thing we said is we need to build a completely stateless machine of not just the customer interaction at a point in time, but it's a stateless machine across all the data elements that is associated with that customer or for that interaction. So how do you build a stateless machine that can stay, that's resilient, but it's also available when the sessions are active, when a customer calls or comes to an online channel? Second one is obviously existing investments. There are too many layers, there are too many multiple touch points in terms of the whole interaction. So how do you make it resilient across all the layers? It's not a greenfield approach where I can say, let me build great microservices and each component living in its own containerized environments. So we said that's really not possible. So we really need to make every single layer resilient. Not just resilient, it also has to do with scalability. How do I scale? Because obviously there's Black Fridays, there's Boxing Days in different countries, there's different peaks that they get in. The first of the month, there's huge peaks. How do we handle for scalability issues? I can't provision huge amounts of hardware, so how do I manage elasticity in the application layer? And of course, it's not just about resiliency. How do you make sure that systems are autonomous enough? How can systems be autonomous enough that they can recover from known failures, at least, if not unknown failures? And end of the day, since it's all about data, it's all about transaction processing, and since it's a bank, I can't afford to leave transactions in a dangling state. So how do I build compensating transactions across these thousands and thousands of transactions coming in per second, and also achieve eventual consistency of the data level? So I'm going to let Raju talk through some of the solution components and the strategies that we had used to solution this. But fundamentally, it was about these design principles, making sure that these thousands and thousands of transactions coming in per second, at the very least, on a committed transaction, systems are absolutely resilient. Uncommitted transactions can't do much, but at least at a committed transaction, it's absolutely resilient, number one. Number two, the data availability is not just for the last 1 month, last 2 months, last 3 months, but data is available for eternity. If I can model that data if I can model the database in such a way that I can provide all the data that's required for the customer interactions, bringing in variety of data, including third-party data, first-party data, social data, neural type data models, how can I cater that in a highly resilient manner? This program is still ongoing. It's about 2 years in making now. It's still ongoing. So there's lots of changes that we have done over the periods of time. So I'm going to let Raju talk about some of the solution strategies that we adopted. Raju.
Thanks, Kiran. Am I audible? All right, okay. I'll start out with a fundamental constraint that was imposed on us, right? We had to live with that constraint. Constraint is legacy system, right? We have to live with those legacy systems, and that has become even more complex when you talk about multiple products from a banking perspective. You've got a checking product, you've got a savings product, credit card, loan, multiple other products, right? Foreign exchange, multiple products. Each product is using a different and disparate and diverse legacy system, right? So that's a challenge or a constraint that was imposed on us. While we live with that constraint, how do we deliver that customer experience is what we were actually, the solution that was built around that, right? Deliver customer experience, and at the same time, process the transactions that are coming in, which are payment transactions, at a very high speed and velocity and variety that is coming in from a data structure perspective. Right? It's a slightly busy slide. I'll try to simplify this.
This is actually a very simplified version of the architecture.
Yeah, it's a simplified version of our solution that we have put together, but again, it looks complex. I'll try to simplify this. So fundamentally, there are three areas that we looked at. One is, we've got a legacy system, the core processing and ledger processing is happening in a batch mode, and that is happening at the end of the day, every day. Now, how do I, and they generally, process in terms of file formats, right? Some systems have got mainframe, some systems are running on AS400, legacy in nature. Now, the first fundamental aspect that we looked at is how do I get the data out of legacy system? Because, fundamental challenge today they had was the storage constraint on the legacy system. So we had to introduce a batch processing component, which is predominantly picks up the files end of the day, which is pushed by these core systems, and we basically does the ETL job on those files, and then push it into our data store, right? That's a first aspect to for us to tackle. The second problem is the speed and the rate at which the events are coming in. Because core transaction manager is used by multiple products and also in multiple regions. When the payment is made by a customer, it basically the core transaction manager intercepts that payment and it raises an event. So we are talking about 10 million customers, and we are talking about 1,000 to 1,200 transactions per second which are coming in. And how do I process that in real time? And each product has got a multi structured data, because we are talking about COBOL copybooks and all. And how do I process data in a real time? And at the same time, balance change notifications and transaction change notifications. How do I basically keep it available for channels to consume? Once the customer swipes the card, when he goes online, whether a mobile banking or online banking, he should be able to view the transaction, and he should be able to view the change in balance, right? So it is happening at a very extremely low latency and extremely fast, right? So that's the second aspect. And the third aspect was around information retrieval, right? So we are talking about, if you look at it from a domains perspective, we are talking about account domain and a transaction domain. We've got a product domain as well, which is a reference data. How do I bring this account and transaction data domains and keep it closer to the channels, closer to system of integration, engagement layer, right? Today it is system of record. I need to pull that data and keep it closer to the channel so that information retrieval happens at a faster, from a responsive performance perspective, right? We are talking about a 0.5 second is the response time for the information retrieval, right? So that was the third aspect. Fourth is basically, it's not really an aspect, but, we said, when we looked at the size of the data, it came to around 15 terabytes, right? And it was supposed to grow for next 2 to 3 years, somewhere around 18 to 19 terabyte, right? Now, do I need to push 15 terabyte data into system of engagement layer? Maybe, maybe not, right? When some So what we did was we looked at the existing customer experience analytics data, which is basically behavioral data of the existing customers to understand the usage patterns. What we found is that majority of the customers are accessing 80% of the customers are accessing most of the data, which is basically within 6 months. Any data prior to the 6 months is basically, we have seen very less number of outliers in terms of the usage patterns. So our main goal was to address 80 to 85% of the customers who are actually accessing majority of the transactions are basically, give me my balance. What are the transactions that I made today? What are the transactions that I made for the last 15 days? What are the transactions that I made for the last 30 days or 3 months? So majority of the customers are falling into that information retrieval of that 6 months of data. So what we decided to keep the 6 months of data very closer to the channels in a real-time data store. And beyond 6 months till about 5 years, we said we'll put it in the database, which is basically below the memory grid that we proposed there. And we used Apache Geode here from a data grid perspective. So that was a high-level construct of the solution and how we kind of approached the solution, right? So as I said, the data is coming in at a very high rate. How do we basically process the data? And the correlation is another aspect which is critical that for us to understand the group of related events coming in, because balance change event comes in and then you'll get a transaction change event comes in. So it's important for us to correlate those events, group those events. So as core transaction manager emits an event, we have an event streamer which pushes the events into a queue. And we have set of listeners will pick up that message and the event, pushes it to validate and transform. This is where the identification of the product, it basically validates the transaction and also it enriches the transaction, because one of the issues that they had was the quality of the transaction data was very bad in today, right? So we got to enrich the transaction. So as we receive those events, we have transformed and enriched the transaction event, and then we have written that into a data grid. And data grid is the way we have configured the data grid is it a multi-partitioned data grid. I'll talk about that, the partitioning strategy in the next slide. And once it is written into the data grid, and we left it to the data grid to asynchronously write it behind into the data store, because we don't want to do it within the same transaction while the transactions events are coming in, and we don't want to affect the throughput, right? We wanted that high throughput, so we wrote it into the memory and asynchronous write that happens from Geode cache to database, which is the write behind feature of Geode cache. And this is configured for horizontal capability, because your Geode clusters and asynchronous listeners and the nodes, there is a redundancy established there. And all the Geode nodes, as and when the data is receiving through the write, it queues up within the cluster, and then based on the batch configuration, it writes it into the database. That was a configuration there. So specifically from a Geode perspective, some of the strategies that we have adopted, as I said, it would have been happy for us if we didn't have legacy systems, right? But we have to live with those legacy systems. So at the same time, how can I retrieve the data from an information retrieval perspective, and the responsiveness that needs to be addressed, right? If you look at it, one of the features that we used is we partitioned the data within Geode, and we talked about account domain and the transaction domain, and account has got related transactions. So the way we structured our partition is account data is partitioned by account number is the key, and transaction data is partitioned by month as the partition, and indexed based on the date and the account number, right? So that is that. So we had a weekly partition from a transaction data perspective, and also a lot of retrievals that are coming from the end users is predominantly either today's transactions, last 15 days transaction, or last 30 days transaction, or last 6 months of transaction. So that's the reason we adopted a strategy to index them from a search retrieval perspective by date and account number, right? So this is one of the strategies. The second strategy, as I said, I think we briefly touched upon, is the right behind. We don't want to be part of that expensive I/O operation that happens when it is written into the database, and we are talking about a 15 terabyte data, and obviously any write to that 15 terabyte data will be expensive. So we have used Geode's capability there. The third strategy was the co-location of data, because account 001 and the related transactions for the account 001, I want those account summary and the transactions on the same node or a same member, right? That way I can avoid some of the network hops that happens when we do the searches and the retrieval. So co-location is one of the great features where you can define saying that I want account and related transactions to be stored on the same member, right? That happens with both primary and the secondary copies. Then we said replicated region strategy. This is one of the strategies we kind of adopted when it comes to reference data and the product master data. I mean, we had a very small data set from a reference data perspective, and we said why not configure it as a replicated region, so that the data is replicated on each and every node within the cluster, right? Unlike partition data, only the primary copy and there is a secondary copy in a different node, right? You have a primary copy and the backup copy, which is on a different members. And here it is basically the same copy is available on the all nodes, right? Then transaction consistency was important for us because we don't want to show something which is inconsistent transaction data to the customers. What we did was again, since our transactions and account domains are configured as partition region, we said we leverage the inherent capabilities of Geode here, which is what it does is if you write it on your node 1, if that is the primary copy of the data that you are trying to write, that node will basically establish as a lock on the secondary backup node and writes it and distributes those changes into the secondary node, right? That happens in a single transaction. Since it is happening within the memory, we were okay in terms of, there is a little bit of a latency issue, but we were okay because it is happening in the memory, not on the hard disk or a database. The other strategy that we looked at is resiliency. How do we achieve resiliency? Given that we have these large data sets sits within the Geode cluster, right? Again, we leveraged Geode's capability here. What we did was we configured Geode's WAN gateway, bidirectional replication capability. So it is configured as active-active DR, and when the change happens or when the data is written into site 1, and from site 1, all the changes that needs to be replicated into site 2 gets queued up on a particular node, and the queued up data is replicated onto the site 2. And the way the data is replicated is through asynchronously between the sites, and also the data changes are happening very similar to the transaction consistency that we have seen in the previous slide, which is it picks up the primary copy of that particular data in the site 2, it writes it into the site 2 primary copy, that will establish a lock onto the secondary copy, and the changes are distributed onto the secondary copy. And that's how the transaction consistency between the sites is established. And since that is active-active, changes are happening, either on site 2 or site 1, and back and forth the replications are happening. We have used asynchronous capability of Geode there, right? So what we delivered so far is basically, obviously a high throughput, scalable and performance solution, which delivers a consistent experience to the end users. And we have taken a customer-centric approach here because experience is one element, and it is not just about look and feel, right? We got to look at how we can do with the technology that we have to deliver that experience end to end, right? So the consistent experience across the channels, across the devices, it's important for us. And the transaction data, quality of the data is important for us. The second outcome is consistency of the transaction, because that's very important in the retail world. When the customer is making a payment transaction, and if you don't see that transaction, and if you are delivering that transaction and the balance change after a few hours, then potentially customers think that there is something happening with the system, right? So the consistency and the real-time consistency of the data is important, and that needs to be, from a customer experience perspective, it is important aspect. And the third one is resiliency. Resiliency in terms of the failures within the cluster and also across the sites. We had site 1 and site 2 in the span of the distance between those two sites was about close to 14 miles between those two sites. So we were able to achieve with low latency in terms of the replication between the sites. Pretty much we have used Geode's capability in terms of achieving this high throughput, high performance, and also data processing kind of a design. That's all we have. We are happy to take some questions. Yeah. Yeah.
In one of the slides, how are the changes pushed from system of engagement to system of records? I saw in system of engagement you have a layer where you have your database and the geode. So changes would be happening there. How does it flow to system of record? Yeah, the last one.
Yeah, so you see that CTM over there, the core transaction manager. So core transaction manager was configured to receive bidirectional events. So transactions happening on the system of record would get pushed through the core transaction manager.
Yep.
And when transactions are coming in through the front, those transactions will also be pushed as events into the core transaction manager. And there was an ACK-NACK mechanism built in inside of the CTM. So when the transaction gets posted into the system of record, it would push back saying that yes, the transaction has been committed.
Okay. Did you ever face the challenges where some of your write behinds failed?
Yes.
How did you deal with that?
Well, I think Geode is still evolving to that extent in terms of ensuring consistency across, especially when it comes to high throughput. We're writing thousands of transactions per second using a write back. There are issues. On a single node, you don't see those issues, but when you go to a multi-nodal models, that's when we see issues. The way we sort of got over that was right at the front when the events are coming into the event streaming engine. There was an atom that was being generated, sort of a unique identifier across every transaction. And that atom could be reused to recreate the transaction data. I mean, there's lots of complex algorithms that was being used. I don't want to get into the details right now, but the concept was there was an atom that was getting generated, atom was persisted, and atom could be used to regenerate the transaction itself.
And then we relayed and replayed.
Replayed the atom.
So that
So that is the autonomous behavior that we built in.
Yeah.
It's not an AI-based system, but it's sort of a rule-based configuration model where how you can take an existing atom, replay it to get back to the original transaction that came in.
Yep.
And as I said earlier, only committed transactions were resilient. Uncommitted transactions we said we can't achieve. It's extremely hard to achieve uncommitted transactions as fully resilient models. And also given the fact that we're working on multi-model data structures, especially when you got into neural type data, it is extremely complex. There's not linear streams, they were network-based streams, especially with third-party data. Yeah. first question, what database? Although our original recommendation was to go with a NoSQL database like Cassandra, the bank was not very comfortable using Cassandra. They started using Oracle. So that is the first one.
Yeah.
Of course, there's some pilot work that's going on to remove Oracle and get with Cassandra, or the data stacks version of Cassandra. So that's the first one. Sorry, what is the second question?
Second one was
The distance between the two data centers, I said it was about 14 miles, about 20 kilometers apart in the geography. So it is not country-wide, it was within the same city. So it was a city WAN network was used.
do you feel this model would serve the same purpose or would work in a cross-country?
So cross-country design, it would not really work, especially if you're, let's say, crossing over 70, 80 miles apart. Then you can't get into city WAN networks. You've got to go for real RWAN networks. And that would be a challenge. But here, the transactional consistency was expected to happen in under 1 second. So within that 14 miles, 20 kilometer radius, we were able to achieve it under 1 second.
Yep. I mean, the more the distance, the latency increases.
I mean, we have done some other experiments on networks over 100 miles apart. It does take about 2 to 3 seconds for transactional consistencies.
So on that third question, the account, so you guys are working at the account level?
Yes, it was at the account level. As you saw, the
level.
partition in the memory was a weekly partition, so every week, and within the partition you had a date index, a date and a time index. So you could really get down to the account level. So date and account level index. So you can get down to the account level.
So how did you solve the customer experience when the original goal was going from 3 months of online activity
Yeah.
and being able to get it to 5 months?
Yeah.
Sorry,
So there were
5 years.
there were two different queries that was being fired. So the query would come in, the query engine would pick up the query, know the date ranges that was expected, and if the date crossed, so there was a registry that was being maintained for what was the last cutoff date, and when it said weekly partition and 3 months, it was not exactly that on the third month you cut over the dates. It was left for a week after the third month. So what you do is in the registry, it would tell you what is the available date window in memory. So the query that came in would get split into two separate queries, because obviously an Oracle query would not work on a geode database. So the query on the geode was different, and the store on the back was different. So it would split into two queries, and there was an aggregation engine that would aggregate the responses back.
There were any sync problems with that?
There were not synchronous problems, but the response time was an issue. Especially if somebody said, some vague query like, give me my last 5 years transactional data on a daily basis. Those responses would take 15, 20 seconds, because you're asking for 5 years worth of data.
Thank you.
And mind you, the secondary database was a pure read-only database. It was not a transactional, it's not a write-only database. The Oracle database was a read-only database.
So you have the core transaction model.
I think we have to.
I think we're running out of time. Maybe I'll take one last question.
So the core transaction model which you showed, so all the legacy applications and the systems, they were implemented at the same time to start using the core transaction?
No.
No,
The
it
core
was-
transaction manager was at least about 10 years old.
Yeah.
They were built on traditional kicks and MQ and RTIs for AS400 systems. And in fact, they even had a flavor of EMS for some of the distributed systems as well. But that is an old legacy platform as well. What we were receiving on the front was a series of streaming events. Of course, the first interface that we built was on MQ, but does support streaming on SAMSA and other protocols as well.